Hi there, class. This is Mrs. Albright, and today we are working on Module 5, Lesson 10. And our objective today is to use the area model and division to show the equivalence of two fractions. So similar to what we did in class the other day, we are taking little pieces, small fractions, and putting those pieces together so that we have a fewer number of units. Each unit is larger. The first fraction we are going to look at is 10/12. Now, to start off determining how I'm going to break this out, I want to think about what are all the factors of this number. So if I think about the number 10, my factors are going to be 1 and 10, 2, and 5. Those are the factors of 10. Now I want to list all the factors of 12. I'm going to start with 1 and 12, 2 and 6, and then I also have 3 and 4. Now, if I look at these two sets of factors, I need to figure out, well, which factors do these two numbers have in common? And the correct answer to that would be 2. So I'm going to draw my area model, and I'm going to break it into 2 vertical rows. And remember, I want 12 pieces all together, so I'm going to think in my mind 2 times what number would give me 12 altogether, and the answer is 6, so that means I need 6 boxes going across. So now I have my area model with 2 by 6 giving me 12 boxes altogether. I'm going to shade in 10 to represent my original fraction, 10/12. Now I'm going to take this original fraction, 10/12, and I want to ask myself, what size groups can I divide this into in order to make bigger pieces, even though I won't have as many of them? And so when I'm looking at this, when I look up at my factors, I notice that 2 is the factor that they have in common, so I am going to circle groups of 2. Now basically what I'm doing is I'm dividing these 12 pieces into groups of 2. So down here for my division sentence, it will be 10 divided by 2 and 12 divided by 2. And if I divide across the top, 10 divided by 2 is 5, 12 divided by 2 is 6. And that is exactly what I am now showing in my area model. Instead of 10 of 12 equal parts shaded, now I have 6 groups, and 5 of those groups are shaded. So the fractions 10/12 is equal to 5/6. Those are equivalent or equal fractions. Now we're going to take a look at the fraction 6/10. And again, we're going to start off by listing all the factors. The factors of 6, we have 1 and 6, 2 and 3. For 10, we just did this on the previous slide. We have 1 and 10, 2 and 5. So then we want to circle the factors that they have in common. And I see that the factor 2 shows up in both of those number lines. So again, I'll draw my area model. And I'm going to make 10 equal groups. Okay, so since my denominator was 10, I've got 10 groups. And I'm going to color in 6 of them. 1, 2, 3, 4, 5, 6 to represent my fraction 6/10. Now, since my factor that I had in common was 2, I'm going to make groups of 2. 2, 2, 2. And if I take my original fraction, 6/10, I'm dividing the 6. I'm dividing the 6 by 2, and I'm dividing the 10 by 2. So dividing across the top, 6 divided by 2 is 3, 10 divided by 2 is 5. And again, looking at my area model, if I continued to make groups of 2, I would have 5 groups of 2, and 3 of those groups would be shaded. So I can prove that 6/10 is equal to 3/5. One more example, we have the fraction 8/12. So I'm going to start by listing all the factors. So we have 1 and 8, 2 and 4 for the number 12, 1 and 12, 2 and 6, 3 and 4. Those are all the factors of 12. Now, looking at these factors, I have some more factors in common. I see that 2 is a factor they have in common, but I also notice that 4 is a factor they have in common as well. So let's draw some area models and see what happens when we use both of those factors. So if I have the factor 8/12, I'm going to divide this into 2 rows. Now I've got 12 boxes, and I'm going to shade in 8 of them. Okay, I'm going to draw the same area model. And I'm going to color in 8 over here as well. And we are going to make groups that are different sizes. All right, so for the first one, we are going to make groups of 2. And so that would be like taking the fraction 8/12, and we would do 8 divided by 2 and 12 divided by 2. So let's circle my groups of 2. And I'm going to ask myself, how many groups of 2 did I make? And the answer is 6, which is my bottom line. 12 divided by 2 is 6. And how many of those groups of 2 are shaded? 8 divided by 2 is 4. Now down here, I'm going to use my larger factor. You'll notice that 4 is the larger factor that they have in common. So I'm going to make 1 group of 4, 2 groups of 4, 3 groups of 4. So if I take the same fraction, 8/12, and I divide it by 4 on the top and the bottom, because remember, whatever you do to the top, you must do to the bottom. 8 divided by 4 is 2, and 12 divided by 4 is 3. So what we want to look at now are these 3 fractions. I have 8/12, which is equal to 4/6, which is equal to 2/3. If you remember, in 8/12, we had very small pieces, and many of them were shaded in. When we divided them into groups of 2 and we composed the fraction that way, we had fewer pieces, and some of them were shaded in. 4 of the 6 pieces were shaded in. And then finally, when we used the largest fraction that those factors had in common, we got the fewest number of big pieces. So we would refer to 2/3 as simplest form. We would not be able to make this fraction any simpler. So the last one I want you to work on yourself. I need you to draw an area model for 4/6, and I need you to tell me what is this fraction in its simpler form, thinking about dividing it by the largest possible common factor. Thank you. Have a great night. I will see you in class tomorrow, and we'll keep working on this.